All right, testing. Testing the audio. All right, testing. Testing the audio. All right. So greetings, YouTube. Greetings, scholars. So we're here for the next installment. So I think this is the fourth item. This is College Algebra 1 for Morris Brown College fall of 23. And this is gonna serve as like a copy of my full official lectures that I can use going forward. So now we're gonna be moving into chapter 2 with set theory. And again, we're using this Blitzer Thinking Mathematically 7th edition. And we're going to start with section 2.1, basic set concepts. A few objectives here. We like to use 3 methods to represent sets. Define and reorganize the empty set. Use this symbol as an element of and is not an element of, or belongs to and is not belongs to. Apply set notation to sets of natural numbers. Determine the set's cardinal number. Recognize equivalent sets. Distinguish between finite and infinite sets, and recognize equal sets. So a set is a collection of, a set is a collection of objects whose content can be clearly determined. Elements or members are the objects in a set, right? A set must be well defined, meaning that its contents can be clearly determined. The order in which the elements of the set are listed is not important. Right, so a set is just a collection of objects whose contents can be clearly defined. It's just a collection of things. You have to forgive me, it's like 5 in the morning. I'm trying to get a stream in, 1 or 2 in before I start engaging students. Methods for representing sets. So capital letters are generally used to name sets. A word description can designate or name a set. Use W to represent the set of days of the week, right? So this is just an example. Use the roster method to list the members of a set. So the days of the week W, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, right? Notice that, where's my? So this symbol here, it just means it's like is a set of. So it's like W is a set consisting of Monday, Tuesday, Wednesday, Thursday, Friday, right? This curly bracket just means a collection of objects. So commas are used to separate the elements of the set, and then curly brackets or braces are used to designate that the enclosed element form a set, right? Okay. Write a word description for the set. P is the set Washington, Adams, Jefferson, Madison, Monroe. What are the P is the set of the first 5 presidents of the U.S. Right. So we could say like P is a collection of the first 5 U.S. presidents. P is a set of the first 5 presidents of the United States. Right. Right, using the roster method. So set C is a set of U.S. coins with a value of less than $1. Express a set using the roster method. So we would say something like C is the set. You have what? Pennies, nickels, dimes, quarters, and half dollars. And you say C equals curly bracket. You list out those coins and then close it up with the curly bracket. You see it here. C is the set penny, nickel, dime, quarter, half dollar. I don't remember the last time I seen a half dollar, let alone when it's been used anywhere. Right, so set builder notation, set W is, again, the curly brackets means the set of all elements X. This vertical bar here means such that X is the day of the week, right? So again, W is the set of all X such that, and then you just read the rest. Let's walk through that one more time. set W is the set of all elements X such that X is the day of the week, right? So we read this notation as set W is the set of all elements X such that X is a day of the week. Before the vertical line is the variable X, which represents an element in general. After the vertical line is the condition X must meet in order to be an element of the set. Express this set A using the roster method, right? So they want us to list it out. I guess I'll go ahead and do this one. Okay. So A is a set of all elements X such that X is a month that begins with the letter M, okay? So then A is gonna be what? Set, let's go down the list. January, February, we have March, April, May, June, July, August, September, October, November, December, right? So just those 2 months. So then empty set, let's click here. The empty set, also called the null set, is a set that contains no elements. The empty set is represented by, we might have like an open closed curly brackets that's empty, or an O or a 0 with a slash through it in this fashion. These all mean the empty set or the null set. It's basically a set with no elements inside. So these are examples of empty sets. The set of all numbers less than 4 and greater than 10. There are no numbers that are less than 4 while simultaneously being greater than 10. Another empty set would be the set of all X such that X is a fawn that speaks, right? In this reality, we don't have talking fawns. So as far as we're concerned, that's another empty set, right? It has no elements in it. Okay. So which of the following is the empty set? Well, no. So for part A, it contains the element 0. So it's not part A. Part B is just the number 0. That's not an empty set. So it's not that one. Right? So this is the set containing one element. This is a number, not a set, right? Let me see. The set of all X such that X is a number less than 4 or greater than 10. I think the example we saw before said and. So you have numbers that are less than 4 or greater than 10, right? Notice that 3 is less than 4, so that could be in here. Basically, I mean, you have an infinite number of, that's not the empty set, right? You have elements in that set. The set of all X such that X is a square with 3 sides, right? One of the main properties of a square is that it has 4 sides, right? So D is an empty set. That's the first one in this that we've come across that is officially an empty set. Because you're not going to have a square that has only 3 sides, and it's going to be a triangle at that point. So for part C, again, it's no, this set contains all numbers that are either less than 4, such as 3, or greater than 10, such as 11, right? So it's infinite set of numbers that, an infinite number, that set has an infinite number of numbers. I didn't want to say it that way, but yeah, that's what it is. The set X is the set of all X such that X is a square with 3 sides. Yes, there are no squares with 3 sides, so that's an empty set. Okay. Notations for set membership. The notations is an element of and is not an element of. The symbol here is used to indicate that an object is an element of a set. The symbol E is used to replace the words is an element of, right? So it's fairly simple to remember. It looks like an E. It just means is an element of or belongs to a set. And then the second symbol with the E with the slash through it is used to indicate that an object is not an element of a set. This symbol is used to replace the words is not an element of. Okay. So determine whether each statement is true or false. R is an element of the set, right? So we have A, B, C. So this is basically what the letters of the alphabet, and the ellipses mean continue the pattern, right? So we're just listing A, B, C, D, E, F, and something like this, you wouldn't list out all 26 letters of the alphabet. You would start the pattern, and the ellipses mean continue the pattern. And then because they finish with Z, it means stop when you get to Z. So if we list out the letters of the alphabet from A to Z, this is a true statement, right? So we're saying that A is true. We're saying that this one is true, right? R does belong to the set. 7 does not belong to this set. That's true, right? Because this is the set from 1 to 5. The integers from 1 to 5, so 1, 2, 3, 4, 5. 7 is not in this set, so that's true. I don't know what I'm writing. There you go. The set A belongs to the set containing no, right? Notice that, like for instance, for part A, R belongs to the set. This set doesn't belong to the set. This set is a subset of this one, but this set is not contained in that set. So this one is false. Okay. True, true, false, right? The set A is a set, and the set A is not an element of the set A, comma B, right? If it didn't have the curly brackets or the braces, then it would be true, right? If it was just A belongs to this set, then it would be true. But because of the curly brackets, that set is not contained within this other set. So sets of natural numbers. The set of natural numbers where we have 1, 2, 3, 4, 5, so on and so on, just continue for infinity. The 3 dots or ellipses after the 5 indicate that there is no final element in that, and that the list goes on forever, right? So natural numbers are basically your positive counting numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and just keep going on forever, right? This is one way that as mathematicians we capture forever. This concept of forever, we'll use ellipses, continue the pattern, right? Continue the pattern. Okay. So express each of the following sets using the roster method. Okay. I'll do it in purple. Set A is the set of natural numbers less than 5. So that would be A is the set natural numbers less than 5. So then 1, 2, 3, 4. Set B is a set of natural numbers greater than or equal to 25. Greater than or equal to 25. So that should be 25, 26, 27, and you continue forever. E is a set of all elements X such that X is a natural number and X is even. Okay. So the even natural numbers. So it's going to be like 2, 4, 6, 8, and continue the pattern. Okay. I feel like that's not too bad. 1, 2, 3, 4, 25 on up, and the even natural numbers. 25 on up, and the even natural numbers. Okay. Okay, at least that hides. I like that hides. I don't know how to bring it back though. Yeah, so like basically what it is that Notability has like recently done updates, and so I'm still getting used to all their updates and certain little display things. Inequality notation and sets. So inequality symbol and meaning, and then we have set builder notation and the roster method. So for instance, for this first part, X is strictly less than A, right? So this is the set of all X such that X is a natural number. And strictly less than 4. I don't know why they're restricting it to naturals, but that's fine. So is a set of all x such that x is a natural number and is strictly less than 4. So the natural numbers that are strictly less than 4 are 1, 2, 3. X is less than or equal to a. It's a natural number and it's less than or equal to 4. This is like an example. So, and then the far right is the roster notation of that example. Okay. So when when x is strictly less than some number, you're talking about all the, like if you look at the number line, we're talking about all the numbers to the left of that number, and you cannot be equal to that number in question. But then for this one, not only are we talking about all the numbers to the left of that number on the number line, but we can also include that number itself because it has that equal to bar under it. Here we're talking about all the numbers to the right of the number without including our number. And then this one is all the numbers to the right of our number, also including the number in question, right? So, you know, mathematics, a lot of times we're talking about precision, right? Are we talking about, we're either talking about like specifically at that number, or what happens when we're close to that number on either side. So that happens a lot, right? Either we're talking specifically that number, or what happens when we're close to that number on either side, or like what happens on the either side of that number, right? That's what a lot of the discussions are about. We have compound inequalities. So for instance, x is between a and b, exclusive, right? In other words, I'm saying that we're talking about all the numbers between a and b, excluding the endpoints a and b, right? And then this is the same thing, but we're including, or it's inclusive of the endpoints. This is like a half interval. You include the left endpoint, but exclude the right. This one, we exclude the left endpoint, but include the right. Okay. So express each of the following sets using the roster method. Okay, so basically a list. It's a set of all x such that x is a natural number and is less than or equal to 100. Okay. So a natural number, I'll just call it A. Or I guess we don't have to give it a name. So if we're going to list out this roster, natural numbers less than or equal to 100. So that's 1, 2, 3. Continue the pattern until you get to 100. Okay. X is a natural number and X is greater than or equal to 70 and strictly less than 100. So then that one will be 70, 71, 72. And we continue until we get to, if we can't be equal to 100, that means we'd stop at 99. Okay. Let's keep going. Okay, we got about 11 more slides. So cardinality and equivalent sets. Definition of a set's cardinal number. The cardinal number of a set A represented by n of A. Oops. N of A is the number of distinct elements in the set A. The symbol n of A is read n of A, right? So when we see this symbol, we're talking about how many elements are in the set A, the number of elements in the set A. Repeating elements in a set neither adds new elements to the set nor changes its cardinality. So we don't count the repeats. So find the cardinal number of each of the following sets, okay? So then the number of elements in set A, it's like it's what, four distinct elements? So it should be 4. The number of elements in set B has 1 element, 0, right? So we're going to say 1 there. I think that's 11, right? Because it goes 13 to 23, and that's 10 steps, but you also have to count, like there's 1 additional, right? If we move 10 spaces, we will land on 23, but you have to count that first initial starting point as a space as well. So then the number of elements in C should be 11. Let's just go with that. And let me do the following. I'm a fan of boxing my final answer, just so it helps it to jump off the page and just be clear. And obviously in this example, it's not really necessary, but since it happened. Okay, we got 4, 1, and 11, and I think you can confirm. You see the 4, the 1, and the 11, right? Like, it seems really trivial, but being able to count this stuff is not as simple as it may seem initially, right? But actually counting is like a major topic in mathematics, right? Because like it comes into play like, okay, say you're a city official, you want to make sure you have enough license plates so that each citizen has a distinct license plate. You don't want people to have repeat license plates. That can cause a lot of trouble, right? You have a law-abiding citizen going to work, doing everything they do, pay the taxes, yada, yada, yada. If there was like a criminal citizen that had the same license plate, that would suck, right? Somebody's, running lights and triggering speed cameras and red light cameras and doing all this stuff, and they had the same license plate as you. Man, I would be so pissed off. I was like, yo, that's not me. It's clearly that, that would be annoying. But anyway, yeah, so you want to make sure. So then it's like, okay, well, how do you count, how many citizens there are? Then that's where like the census will come in. Say, what else? Anything like with a lock or IDs, or, you want to be able to make sure that you can create enough unique IDs so that there are no repeats. Like if you're, if you don't, like if you were creating a social security number for people, and it wasn't set up properly. Let me think. Our social security numbers consist of what? 8 digits, and each placeholder has 10 options. So that's 10 to the power of 8. Real quick, I just want to see something. I can do this. 10 to the power of 8. So that's going to be a 1 with what? 1, 2, 3, 4, 5, 6, 7, 8. What number is this? 1,000 million, 100 million. Wait a minute. How many citizens are in the U.S.? 100 million? Are we not in the billions? Like, now I'm thinking about it. I'm like, hang on. I'm sorry. I went on a random tangent. I have to get this answer now. Let me see. Hey Siri, approximately how many citizens are in the United States? Oh. Let me try Google. Hey Google, approximately how many citizens are in the U.S.?
On the website commerce.gov, they say U.S. population estimated at 332,403,650 on January 1st, 2022.
She said,
as our nation prepares to ring in the new year, the U.S. Census.
Hey Siri, hey Google, stop. Jesus. What? What? Hey Siri, stop. Man, oh my God. Thank you. So that was kind of trippy because, so how, like if we have 300 million and, social security numbers are like 8 digits, what's going on with that number? Like that's kind of weird, right? It seems like that, unless I didn't do the calculation right, all right, it's 8 slots. You have 10 options. I think you can have zeros in there. I'm assuming you can have zeros. So that's 10 options for each slot. 10 times itself 8 times is basically 100 million, right? 8 zeros. Yeah. So that's kind of trippy because it kind of seems like with that system, we can't create enough social security numbers for each citizen. So then there's one or two things that has to happen. Either the social security number system changes where you would add more digits, or you have official citizens that either don't have social security numbers or potentially, now I don't really think that they are repeating. I just don't know how it's been addressed. Like, how do you address that we don't necessarily have enough social security numbers to cover all the citizens? Like, what's that about? Is it that when people die, but it's, that's still, you got to account for the people that are alive, right? So it's like, if we have 300 million and social security numbers only cover 100 million, yeah, that's what I got. That's kind of weird. I feel like I need to dig into that. That's so trippy. 1, 2, 3, 4, 5, 6, 7, 8. Right there. Right there. Yeah, I'm getting 100 million. We need 3 times that amount. Yeah, that's trippy. Okay, well, I might have to look into that later. I'm sorry for that, but yeah, it was. I don't know. I got to look into that. Like, wait a minute. Do we have enough social security numbers to cover all U.S. citizens? Yeah, so each U.S. citizen can have a unique number, right? Because you definitely don't want repeats. Somebody could be stealing somebody's benefits, or it can lead to a lot of different confusion, right? Yo, that's trippy. But that's what happens a lot of times. It's just fun stuff. This is really interesting. So anyway, definition of equivalent sets. Set A is equivalent to set B means that set A and B contains the same number of elements. For equivalent sets, the cardinality of A is equal to the cardinality of B, right? So we say that sets are equivalent if they have the same cardinality. These are equivalent sets. The cardinality of A equals the cardinality of B, which is 5. So A is a set of all x such that x is a vowel. B is a set of all x such that x is a natural number, and x is greater than or equal to 3 and less than or equal to 7, right? So the elements of set A are the vowels A, E, I, O, U. The elements of B are the natural numbers 3, 4, 5, 6, 7. Notice that both of these sets have 5 elements in them, so these sets are equivalent. They're not equal, they're equivalent, right? The lines with arrows, the line with arrowheads like this, let me see, indicate that each element of the set can be paired with exactly one element of the set B. So each element of the set A can be paired with exactly one element of set B, and each element of set B can be paired with exactly one element of set A, right? So it's a one-to-one mapping. So one-to-one correspondences and equivalent sets. If set A and B can be placed in a one-to-one correspondence, set A is equivalent to B. In other words, we're saying the cardinality of A is equal to the cardinality of B. If set A and set B cannot be placed in a one-to-one correspondence, then A is not equivalent to B, and we write that as the cardinality of A is not equal to the cardinality of B. Oh, we're almost done. We only got like, what is that, 7 slides remaining. So this figure shows the preferred age difference in a mate in 5 selected countries. A is a set of 5 countries shown. B is a set of the average number of years women in each of these countries prefer men who are older than themselves. Are these sets equivalent, and explain? So A is a set of 5 countries shown. Let me see. So the cardinality of A is 5, right? 1, 2, 3, 4, 5, right? The set B is the set of the average number of years women in each of these countries prefer men who are older than themselves. Women. All right, so that would be, looks like that would be the 4.2, 4.5, 3.3, 3.3, and 2.5, right? So one thing we said about cardinality, you would have to have, you count only the distinct elements, right? Even though there are 5 averages, you have a repeat average of 3.3. So we don't have 5 distinct averages. We have 4 distinct averages. So it looks like the cardinality of A should be 5 and the cardinality of B is 4. So we would say that these sets are not equivalent, right? They should not be equivalent. Okay. So the lines of the arrowheads indicate that the correspondence between the sets is not 1-to-1. The elements Poland and Italy from set A are both paired with the element 3.3 from set B. So these sets are not equivalent. Again, the cardinality of A is 5, cardinality of B is 4. So because the cardinalities are not equal, these sets are not equivalent. Counting, right? Set A contains 5 distinct elements, so the cardinality of A is 5. Set B contains 4 distinct elements, the cardinality of B is 4. Because the sets do not contain the same number of elements, they are not equivalent. Okay. So then we have finite sets and infinite sets. Set A is a finite set if the cardinality of A equals 0. Let me see. Sorry. Set A is a finite set if the cardinality of A is 0. That is, A is an empty set, or the cardinality of A is a natural number, right? So we say that a set is finite if its cardinality is either 0 or some natural number. A set whose cardinality is not 0 or a natural number is called an infinite set. Okay. Okay. So then equal sets. So we talked about equivalent sets. So now we're making a distinction between equivalent sets and equal sets. So definition of equality of sets. Set A is equal to set B means that set A and set B contain exactly the same elements, regardless of order or possible repetition of elements. We symbolize the equality of sets A and B using the statements that set A is equal to set B. We say set A is equal to set B means that set A and set B contain exactly the same elements, right? So not only do they have the same number of elements, but then also the corresponding elements match, right? So they're all the same. So equivalent sets have the same cardinality. Equal sets takes it a step further and equates the corresponding elements of each set. So determine whether each statement is true or false. The set 489 is equal to the set 894. Is that true? We're going to say it's true, right? They have the same cardinality along with the same elements. So we're going to say that this one is true. The set 135 is equivalent to the set 0. No, false. Not equivalent, but equal to, but it's still not. It's not equal to. We got true, we got false. Sorry. Oh, that was it. Okay. All right. So, what section was that? All right, so we just completed section 2.1 on basic set concepts, and I will make the next section available momentarily. On that note, we're going to end the session here. Be sure, hopefully you all are taking notes as if you're in class. So these are the full corresponding lectures that correspond to our assignments in My Open Math. Again, I just, for the sake of simplicity, I kind of restricted all of our assignments as far as homework, quizzes, and exams. They're only in My Open Math. So I have to go back into Populi and try to clean that stuff up. It's a lot of stuff that you don't need there, and I don't want you guys stressing out trying to figure out. I just need to hide it. That stuff is really there so I can submit grades and things. And be on the lookout for quizzes in My Open Math. Right now, there aren't any quizzes there. There are quizzes in Populi. I'd rather get those quizzes into My Open Math, so that way all of your assignments, there's one main place that you're looking for your assignments. You're not trying to figure out where are these things. trying to be uniform, right? So more than likely, I'll figure out how to hide or suppress all that stuff that's in populi and try to leave the things that are relevant and, you know, rearrange it a bit. But the main thing is, as long as you're submitting your assignments in My Open Math, that's where I'm going to be pulling our grades from, okay? And on that note, we're going to end the session here. And from one beautiful mind to another, wait a minute. Let me make this available for you all. PDF. Oh no, let me cancel that. Let me get rid of that. Share. Yeah, that's better. See, they're changing options. I think this is you all, but let me just make sure. It's the fall, Morris Brown, notes, update daily. Yes, I don't know before. Okay. I just wanted to make sure. It's in the box. Okay, that's better. All right, so now I've made a copy of all the writing that you saw me doing is now available. It's in the box link. That link can be found in Populi in the announcements section or the dashboard. It was a link that I created the first day. All right, and on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care, guys. Ladies and gentlemen, peace.